Hi, everyone. Just wanted to take a moment to talk about how to solve a system of equations by graphing. So, one of the important things to consider when you are graphing is that you can obviously use things like Desmos to help you and assist you. Um, but ultimately, your first step is always going to be to get them in a form that is beneficial for you. So, in this case, we have one in slope intercept form and we have one in standard form. If you would like them both to be in slope intercept form, you could put them both in slope intercept form. If you wanted them both to be in standard form, put them both in standard form. But usually try and get them in a form that's beneficial for you. So I'm going to put this into standard form to start. I'm sorry, into slope intercept form. So I'll subtract my x from both sides, minus x from both sides. I get 3y equals negative x minus 12. I'll divide by the 3. I get negative 1/3 x minus 4. And then I have x plus 4. All right. So now we have to graph our lines. This one we have starting at 4. We go up 1 and then over 1, and we have our line. So on Delta Math, which I'm using, after you plot the 2 points, it will automatically make your line. If you are using Desmos, if you type that in, it'll work. On Desmos, it's actually super easy because you just type in whatever you're given and it'll give you the graph. All right, and then on this one, we have minus 4, and then we're going to go down 1 and over 1, 2, 3. Now, as you can see right here, our point of intersection is pretty easily identifiable. It is nicely on a line. I'm sorry, yeah, on one of the nice coordinates, and it's not like a fraction. If it was close, you might have to kind of estimate or things like that. Desmos will more actively give you a closer answer if it does get into the decimals, but you just need to be careful and make sure you get it correct in terms of where it's actually intersecting. So do your best. All right, so we are going to the left, negative 6, and we are going down 2. Double check, make sure I did that correct. All right, and we're good. Let's do another one. Funny, it's the same line. I don't want that one. Okay, so now let's start this problem. Let's do this one. And it again will be a very similar one. So again, if you prefer them in standard form, put them both in standard form. If they're not both in standard form and you want one in slope-intercept form, then rewrite them as needed. So minus 3x, minus 3x. To be honest, I don't even usually bother with graphing unless I, number one, have Desmos or something else readily available, or if it's already that they're both in standard, in point, in slope intercept form. So if it's already in a nice form, I usually will just kind of deal with it that way. But if they're not both in the same form, I usually wouldn't graph. In fact, if I'm looking at this, if I was given this on my own and wasn't told to graph it, I probably would have used substitution. But we are graphing, so that's what we can do. So we go up 2, and then up 1, the right one. And then on this one, we go down 6, then down 1, 2, 3, over 1. And again, we have a nice point of intersection at negative 2, 0. Oops, there we go. And we're good. All right, and as I had said, if we had plugged something like that into Desmos, pop that up, what you would have gotten, right, y equals x plus 2, and then 3x plus y equals negative 6, right? You can see right here it does give you the point nicely shaded for you already, and that'll be the point of intersection. Now, if it had been something like, let's say that, see how it's in the middle, it'll give it to you in terms of decimals. Let's say I had something even, these are always going to be like that. Okay, 9.8, whatever. And then, as you can see, it's still giving you them as decimals. All right. So if you have any questions on graphing, please let me know. This should hopefully be pretty straightforward. Have a great day.